Right folks, we are starting exactly where we left off. Just to set the scene then, because it is a bit confusing at the moment, we have now started the tectonics module. If you haven't quite got your module booklet yet because it hasn't arrived in the post or you haven't yet made it into college, you do have access to a digital version. I sent you a link to my hazards folder on OneDrive and specifically the hazards module booklet on OneDrive as well. So you do have access while you're perhaps waiting for yours. Okay, so I'm going to try, I will use page numbers, but for those of you that have printed out a digital copy, I will try to do an alternative as well. We are right at the beginning of the module booklet and we're setting the scene for what we're expecting in this module by doing something that we're calling case study nuggets. And we do this, you know, if life had been normal and we were actually face to face, we would have done exactly the same thing, except we probably would have set you a little bit of individual research to do. In the first video, we looked at 4 volcanic eruptions and sort of pulled out some of the big ideas of this module. We're now going to do exactly the same for earthquakes and tsunamis. We are not expecting to get to earthquakes and tsunamis until the autumn term. So this is just literally a flavour of the kinds of things that we'll talk about. Right then, so we're going to start with probably quite a famous one. We're going to talk about the Haiti earthquake. And Haiti is sort of the Nevado del Ruiz equivalent, if you see what I mean. So Nevado del Ruiz was a terrible disaster. 23,000 people died. It was a real turning point in volcano science, and after that everything has sort of improved. Well, that hasn't happened so much with earthquakes, because the one big thing that you will discover with earthquakes is we still cannot predict them. Many people have tried. There are all sorts of different things and we'll look at those. Some people say you can see weird lights in the sky before an eruption. Some people say you can use chaos theory. Fundamentally, most people have given up trying to predict earthquakes. It just doesn't happen. So we've got volcanoes where if you monitor, predict, evacuate, you should theoretically have hardly anybody dying in volcanic eruptions anymore. Earthquakes, we are definitely not at that point. Haiti, it had the terrible misfortune of being incredibly vulnerable. So Haiti is the poorest country in the Western Hemisphere. You can see the quality of the buildings in that image. They just didn't stand a chance. So it's a complete disaster. It's a slightly depressing case study because of that. I've put 2 hyperlinks here. This is just a load of facts and figures. This is a really good YouTube clip. It's like a day-by-day summary of what happened. It's not gratuitous at all. It's very factual. It's very informative. So I would have a watch of that one if you can. I'm going to be positive for a moment about multinational companies, ladies and gents. Throughout year 1, we're generally not that kind about them because of exploitation, because of cutting corners, because of all sorts of things. But we should just say that Coca-Cola have really tried very hard to help Haiti post-earthquake. If you want a good news story, crikey, we do need probably a little bit of a good news story in the world at the moment, don't we? Then you could have a look at that. That might cheer you up a little bit. So, Haiti, least developed country in the Western Hemisphere, big earthquake, massive disaster. Right, Japan, incredibly tectonically active, one of the wealthiest countries in the world, possibly the most prepared for tectonic activity. This is a case study that sort of proves that sometimes Mother Nature is just too powerful. You think you've built yourself a tsunami wall that you're going to keep the sea out, even if you do. I mean, they know they're going to get earthquakes and tsunamis in Japan. Tsunami is a Japanese word because they get so many of them. They knew it was going to happen. But Mother Nature just sometimes throws you a curveball, something that there's not very much that you can do about. Now, I am just going to show you, I think this is the right one. Yes, it is. So this is what the tsunami thought of Japan's defences. So you can see a wall here. Now, clearly something already has gone wrong. There are cars in the harbour. Something's not right, is it, already? But just notice, as this clip progresses, it's just, oh, makes me feel sick, I have to say, just the thought of being anywhere near this. And that's what the sea, that's the power of Mother Nature. You might think that you had your tsunami wall, but not necessarily, and look at the devastation that does. So this bit of footage, it's not terrible, but it's not very nice either. For the people who say, oh, you could probably be all right in a tsunami if you're in a boat, well, this little bit of footage may make you think twice about whether that would be any good. Just brutal. All right, so what we're saying is that really the point that the Japanese case study makes is that sometimes the hazard is just too powerful, and by all means have a look at those other links there. They're all quite interesting. This last one is quite weird. So it's not necessarily from an educational website, but don't worry, it's not from a dodgy one either. Fukushima, nuclear power plant. Japan relies quite heavily on nuclear power, and the problem is that the Fukushima nuclear power station was affected by the tsunami, and nuclear power produces something called radiation, and radiation can either make you very poorly or it can actually kill you. So there is this massive exclusion zone around Fukushima now, and basically life just stopped. And it's a whole load of photographs. You can go into the exclusion zone for very short periods of time, and a photographer went and just kind of took photographs of, yeah, just the moment that life stopped, really. So all of the people were evacuated, and their houses and their cars and all of their belongings are still there. It's just a bit weird. Loma Prieta. Now, Loma Prieta definitely is not going to be one of our big case studies. It's too long ago. Basically, with EDUCAS, we really want to aim for the last 20 years. They like case studies that are reasonably up to date. There are exceptions to that, because sometimes, of course, you have events that are just so noteworthy that you can bend the rules on that. So as I said to you in the volcano video, I would expect you to know a little bit about Nevado del Ruiz, because it's just so important in the history of volcano tragedies. Loma Prieta, definitely not going to be a major case study, but it raises the question of timing. Does it matter what time a hazard happens? So Loma Prieta has the slightly bizarre claim to fame, in that it became the first major earthquake in America that was broadcast live on national telly, and there's a YouTube clip there if you're interested. Because there was a major game happening, it's likely that the roads were much quieter than they otherwise would have been, which means when that happened, which is just catastrophic, isn't it? When that happened, there were far fewer cars on that freeway than there would otherwise have been. Maybe timing is quite important. It's just a sort of thought to have, really. The other thing that Loma Prieta shows, it's not the only earthquake that does, but it's probably the most famous. There is a secondary effect of there's a secondary effect of earthquakes, get the right hazard, Mrs. Lewis, called liquefaction. And liquefaction is very strange. And when we get to that part of the syllabus, I can sort of show you some demos and things. Essentially, what happens in liquefaction is if you have certain types of geology, as the earthquake shakes the ground, the solid particles separate from any water that might be in the rock, and then the house or the road or the whatever that you thought was standing on solid rock no longer is, which is a bit of a disaster and leads to building collapse, leads to houses nearly falling over but cracking, leads to this kind of effect. But you only get it in very particular rock types, which means as you get better with your science, if you lived in an earthquake-prone part of the world, you would avoid building on that kind of geology. And of course, if you live in a more developed country, that's quite likely to have happened. If you live in a less developed country, you might not have the money or the expertise or the knowledge to be able to do that level of looking. So it's about sort of, again, same as I said for volcanoes, it's the familiar stuff about big earthquakes tend to kill more people, but we also at A-level want to look at the subtle little differences. Does geology have a part to play? Yes, it does. Does level of development? Yes, it does. And so on and so forth. And then Kashmir. Now, Kashmir is a region that involves parts of other countries. It's quite sort of hard to define. So you've got the part of Pakistan, part of India, part of Afghanistan. I'll show you a map in a second. And as you can see, this was a pretty deadly earthquake. And again, it's down to situation, if you like. So here is the rather confusing region of Kashmir. Now, we are talking less developed, we are talking isolated, we are talking rural. And that's quite important because one of the key themes that goes through this module is responses. So you've had a hazard, right? You've had a volcanic eruption, you've had a tsunami, you've had an earthquake, whatever you've had. What you need is to get help to those people as quickly as possible. If you've done very much first aid in your life, you'll know that there's this kind of golden window of opportunity to really make a difference. If you kind of scale that up, the same basic idea is true for any kind of natural disaster. The sooner you get in to rescue people, to tend to their wounds, to get them medicine, water to drink, all of that stuff, the more lives you're going to save. That gets harder in the countryside, it gets harder in less developed countries, and it gets harder in isolated parts. And Kashmir sort of was all of those things. So you can see most of the affected people lived in mountainous regions with access impeded by landslides that blocked the roads. So getting help to these people is going to be really, really hard. Then, as you know from your global governance module, if you have a load of people who are homeless and need looking after, we have the United Nations who will set up camps like this. So we've talked about refugee camps before. Now those tents are good, but they're not going to help you survive a Himalayan winter, are they? A Himalayan winter is going to be particularly brutal. And so what this case study tells you is maybe you don't actually die in the earthquake, but the after effects of that earthquake cause your death, if you see what I mean. So we've got here, people are made homeless because their homes collapse in the earthquake. They're then housed in tents, but they're housed in tents in a Himalayan winter, and actually you die from the cold. So that is a result of the earthquake, but not directly, is it? So you see, you can have kind of causes of death that are linked, but in a sort of slightly odd way. And here's just some of the landslides that happened in Kashmir. So you've also got links here synoptically to mass movement. We talked about mass movement in coasts. So mass movement is where large quantities of material move downhill under the influence of gravity. And in the coastal module, we talked about the idea that the sea attacks the bottom of your cliff and it kind of destabilizes everything above it, and it tends to make cliffs collapse. Yeah. Well, earthquakes shake the ground. And by shaking the ground, if there's anything that's a little bit weak, a little bit crumbly, not very strong, it's going to be encouraged to collapse. And you can imagine if there had have been, you know, anything in the way of housing or anything like that, people are now dead, or if indeed you've lived at the bottom of those slopes and that landslide had happened above. Again, it's sort of to do with location, isn't it? If you've got a massive earthquake and then you've either got the kind of geology that might give you liquefaction, or you've got a mountainous region that's really going to be prone to mass movement, it's the overlapping of these factors, I suppose, is what tends to give you massive, massive death tolls. Okay, now that information will make sense to some of you and not at all to others. Fairly quickly we will get to plate margins, but for those of you who know a little bit about plate margins, for the 4 volcanoes we've talked about and the 4 earthquakes we've talked about, that is the type of plate margin they are sat on. If that might as well be written in another language for you today, don't worry about it. It's really, really not important, okay? We will come back to that another time once we've done plate margins. So they are your 2 little introductory videos, ladies and gents, that might just give you a little flavour of what we're doing, and in the next video we'll start kind of the module properly. Thank you very much.